This is video 2.3. Today we are going to be using deductive reasoning to verify conjectures. So we already did inductive reasoning where you use a pattern. Today we're using deductive reasoning to verify the conjectures that you make after you look at a pattern. So vocabulary. Remember, inductive reasoning, we're using observations to make or find a pattern or a rule. Deductive reasoning, where you're going to use logical conclusions from statements that are known or assumed facts, definitions, and properties. So you've got, it's more objective than subjective. So the law of detachment is one where if your PQ statement is true, P is true, then Q is true. So if the whole statement is true and P is true, then Q has to be true. It's called the law of detachment. And the law of syllogism is if your P to Q conditional statement is true, or if you have an if-then statement that is P to Q, and you have an if-then statement that is Q to R, if they're both true, then P is also if-then to R is a true statement. That conditional statement would be a true statement. So let's say that there are urban legends and modern myths spread quickly through the media. Many websites and television shows are dedicated to confirming or disproving such myths, like Mythbusters. Is each conclusion a result of inductive or deductive reasoning? So there's a myth that toilets and sinks will drain in opposite directions in the northern and southern hemispheres. So if you were to observe the sinks draining in the two hemispheres, you could see that the myth is false. So is this inductive or deductive? So the key word here is going to be observe. You watch it happen. That is inductive. Okay. There's also a myth that you shouldn't touch a baby bird that has fallen from its nest because the mother bird will disown the baby if she can smell you, that detect the human scent. But biologists have shown that birds cannot smell people. There is no human scent that they are detecting. And so therefore that myth cannot be true. So here we are using a scientific principle. So we would call this deductive. So if you're just watching it happen, if you've seen it happen, we're going to use inductive. Deductive is you're using definitions or facts to make your decision. So let's verify conjectures using the law of detachment. So we are going to determine if the conjecture is valid by looking at the pieces of the whole and then the pieces individually. So if two segments are congruent, then they have the same length. That's our given, okay? So that's the first part. So we would say that AB is congruent to XY. So that's our given. That's what we know. That is, when we say a given, then we're going to say that this is what we have. Our conjecture is what we're trying to prove. So we're wanting to show that if the two segments are congruent, that they have the same length. That's the conjecture. So the way we're going to do this, we'll identify the hypothesis and the conclusion in the conditional. So here's our hypothesis. Two segments are congruent. They have the same length is our hypothesis, is our conclusion. So if two segments are congruent, then they have the same length. So we have the statement that AB is congruent to XY. So the given statement, AB is congruent to XY, matches the hypothesis of a true conditional. So we would say that this is valid. This matches it. So since that is valid and this is valid, then we would say that this is valid. All right, let's try another one. So let's say your given is, if you're tardy 3 times, you must go to detention. And Shay is in detention. These are facts. Okay, so if you're tardy 3 times, you go to detention. Shay is in detention. So our conjecture is that Shay was tardy at least 3 times. Okay, so the conclusion here, okay, so Shay is in detention. Does that mean that she was tardy 3 times? So while our given is valid, our conjecture is not necessarily valid because it doesn't say in our given that Shay was tardy 3 times. Now, if we were told Shay has been tardy 3 times, then our conjecture, we could say she has to be in detention. That's not necessarily exactly true, right? So the given statement that Shay is in detention matches the conclusion, but it doesn't necessarily mean that the hypothesis is true. So if our hypothesis isn't true, then it's not necessarily going to be true. So we could say that this is invalid because maybe Shay is in detention because Shay said a bad word, or Shay threw something during chapel and hit somebody in the head. I don't know. There's lots of reasons why somebody could be in detention besides tardies. So the conjecture is invalid. Okay, we are going to verify conjectures using the law of syllogism. At least I think I'm saying that word right. So remember what that is if you've got a statement P, if P then Q, and then if you have Q then R, then you can say that P then R. Okay, so when we go through, we're going to identify the parts of the given and the conjecture to see if they match. So we're going to determine if each conjecture is valid. So let's give our first one. We have the measure of angle A is less than 90, then A is acute. So I'm going to say the measure of angle A is less than 90. We're going to call that P. Our Q is going to be that angle A is acute. And we get that because this is our if-then statement. If P, then Q. All right. Now, our Q should come first in our next statement. If Q, that's still angle, then R, so it is not a right angle, will be R, not a right angle. So if you can divide it up like that, then you should be able to see. Is P to Q true? That's valid. Is Q to R true? That is valid. So then we could say P to R is valid. Let's try another one. Oh, sorry, I wrote all over it. You can't see it now. Our conjecture is if measure of angle A is less than 90, then it is not a right angle. So we take our P and our Q, that's what they have written, our conjecture would be valid. Okay, the next one, if we have our given is a number is divisible by 4, then it is divisible by 2. So let's say our P is a number divisible by 4. Our Q is the number is divisible by 2. That has to be our Q. So now then the next statement is if a number is even, however, in order for this to work, that is supposed to be our Q. It should be P, Q, Q, R. But in this case, we've got if a number is even, so that's new. Let's see, the number is even. Then it is divisible by 2, which would be the Q. So what we have here is PQ, RQ does not follow the correct path for syllogism. Now, while it is valid and it is true that that a number that is even is divisible by true, that is a true statement, you cannot verify this conjecture based on the law of syllogism. Because their conjecture is a number is divisible by 4, then it is even. And while that is true, you can't get there by logical reasoning, and so we would say it is invalid as an invalid excuse. It is an invalid conclusion because they went about it the wrong way. So let's apply the laws of deductive reasoning. What we're going to do this time is we're going to draw the conclusion from the given information. We're going to be given something and we're going to conclude something. So let's say our given is that if a team wins 10 games, then they will play in the finals. And if a team plays in the finals, they travel to Boston. So then we know that the Ravens won 10 games. What conclusion can we draw? So we can do the syllogism on this one. We can say that this is P. If a team wins 10 games, then they play in the finals. And if they play in the finals, then they travel to Boston. So if we know that the Ravens won 10 games, then they must be traveling to Boston. So our conclusion is that the Ravens will be traveling to Boston. Okay, the next one. If two angles form a linear pair, then they are adjacent. If two angles are adjacent, then they share a side. And what we know is that angle 1 and angle 2 form a linear pair. So if you have angle 1 and angle 2 forming a linear pair, so this is our P and this is our Q. This is our Q and this is our R, right? So if they form a linear pair, angles 1 and 2, that means that they are adjacent. And if they are adjacent, then they share a side. We could say angle 1 and angle 2. We can say that they are adjacent. And we can say that angle 1 and angle 2 share a side. So I know that these are a little tough and it takes a little while to get your brain going from doing the type of math you've always done to moving into doing proofs and thinking about things logically. But I think it's a lot of fun. It gives you an opportunity to do math in a slightly different way. So just hang in there. If it's a little confusing, we'll get lots and lots of practice and we'll work through it together, all right? Have a good evening.